Hi guys, Kim, Papa's Fix-It Shop here. Having my coffee. So, this guy is pretty much assembled. It's about half of the stuff has been lapped and fitted, sanded, polished, where things come close to each other that want to move around. And you want to make sure it's nice and smooth for two reasons. One, so that the metal won't, if it touches, it won't start to gall and make a area that's wider and cause it to bind. But also, whatever you're chewing up with this, the plastic, you don't want any irregular surfaces where that is, that it can hang on to it and stick to it. You want it to be able to fall right out. Anyway, and this, I've got the depth adjusting knob. It's all set up. Now the bolt under there has some adjustments I have to make, but I am at that turning point where I gotta mount this motor. Now this little motor, I think it's 13 millimeter. I'd have to measure it. I'm not going to do it right this second, but this little motor has a shaft with a flat machined on it and a keyway. So I'm going to bore a hole in this shaft that just fits this stub shaft. I'm going to take the key out of it, and I'm going to use a couple of set screws. And because of that, I'm actually thinking about it. Because here's the thing, I mean, this is not a highly precise place. When it comes to a motor, that you want this motor to turn this shaft, you can't have any misalignment on any axis of more than 1, maybe 2 degrees. Or else this thing's going to have a spot where it goes around and goes. So I'm actually thinking about getting some kind of coupler, but that part's later, because what I need to do now is mount this. There's another piece of that 4" by 4" by 1/4" structural steel. And what I'm going to do is put the bolt pattern of these pillow blocks right here in this guy, because on this side, that's what happens when you plan ahead. I probably got the wrong bolt in here. Oh, I didn't. See? These are 1" bolts as opposed to the 3/4 that are going through the other one. That's because I knew there was going to be an extra 1/4" right here. So when I'm done, I'm going to make a pattern that goes around these holes all the way out, so this whole hub will just go up flush against this boss on this pillow block and hold this piece of steel that I can use to mount this guy on. That's the plan anyway. So yeah, phase 3 or 4 or whatever of this project. Thanks for watching. Okay, so thought I'd show you this. I started and then I realized this is the pillow block right here. And I've used some glue stick from Walmart to glue this piece of, it's not paper, it's a real thin cardstock. And I've got this set on a couple of steel blocks to hold it up off of this hub. And then 2 pieces of lead to keep it steady. Right, let me zoom it in. So this is the kind of thing with a little hammer, like a little ball peen hammer and a piece of paper. It's mostly used to make gaskets. And you can use the flat side on a flat surface. Follow the corner. Obviously, the sharper the corner is, the easier it is to do this. But you can see the cut go around the paper. Then I'll go with the ball side where it's touching, where there'll be a little bits. There's like a crack or a scrape. All right, so there's now. See, that's the shape of it. Now I go in there. If you push down where the holes are, it'll make a little divot. And then you just follow the edge of that hole around. I've had people ask me what I use this tiny, tiny ball peen hammer for. I've had this guy 40 years. And I cannot even begin to count how many gaskets I've made with it. But you gotta stay on the edge so it doesn't tear the paper. This thing running? Oh yeah, it is. Okay, so this guy, I need to make a. I don't have a tape right here. I need to make a nearly 3-inch hole in there. I don't have a 3-inch saw, and I mean I could chuck it up and bore it, and that's a long way because I go from a 1. I think the biggest annular cutter I have is 1 1/4, and I don't want to go. Buy a $100 cutter to do it. So what I'm going to do is I'm going to punch this thing out of this flat plate with a rotary table in the mill with a really tiny end mill, like a carbide end mill, and just go around a circle and just whittle it away until the chunk falls out. So I've got a hole drill here that shows the center, and I want to put it on here, right? And so then you got to be able to get this center hole of this plate lined up pretty close to the center of this rotary table for it to turn in a circle and make the hole in the right place. So MT2, I got a drill chuck from the little lathe that's the same size. I set it in there. Take a 1/4 inch bolt, which is a 1/4 inch hole I drilled in here, and I stick it through there, right? And I put it in there and get it kind of lined up. All right. Set there, and then I got some metal. I can put one right about like that. There it is. Just like that. So now it's the hole's centered on the middle, and I can unscrew that thing and pull it out. So then it's just a matter of very close tolerances. Drop studs down in there. So this guy is now held with a 3-point attachment, so to speak, because it's only touching right here. Let's see. Yeah, right here it's thin and the back's this big wide plate, so it's going to pinch it down. So then I just get some, yeah, those are going to be in the way. Got to be really careful about what I put in there so that it won't interfere with the end mill. But yeah, so if you ever think about that, what a great way to center up this thing, because now it's stuck in the middle. Yahoo! I'll get back later. Okay guys, so here it is. What I've done is I put the drill into the mill now and lined it up until it just slips through there without touching. And then if I keep going, it goes right through the chuck too without touching. Close enough for government work, baby. Now I put a mill in there and cut a big circle. Okay, well I got this kind of cobbled together. Today is wiring harness day, electrical control day. So I've got this little rheostat that controls the motor speed, and I've run it through a 2-pole, 2-throw on and off toggle so I can reverse it. So let's see, let's turn it on. So right now nothing should happen because the switch is off. But, let me zoom it in. That's too far, isn't it? Can't see crap. Okay. So turn this guy down all the way. Nothing happening. That's full speed at 12 volts. Stop. Reverse. Actually, this is forward. Reverse. And of course, I can slow it down. What I can also do with this power supply is run it up to 30 volts. All right, so now it's a 28.4 volts, and it's pulling about 0.6 of an amp, 5.5, 0.56 amps. If I crank it up at 30 volts, that's 1.5 amps pretty much, without a load. Off. Working good. Bring this guy back down to 12. Let's see. Let's put it on max speed. See if I can get this. There's 12 volts. It's working great. All right, this is 1/2 inch angle iron, mild steel. It's really thin. It's like 1/16 of an inch, give or take, because it's hot rolled. And I drilled 6 5.2 millimeter holes in the center of 10 millimeter spaces, and I'll tap them out, and they're going to make the little tabs that this guy screws to. And so this small of a 1/16 inch thick with a 5 millimeter by 8.0 tap and a little bit of tap magic. Let's see. Just hold it really straight and let it follow the hole. Okay, so I got it locked in there real tight because I was pounding on it. There it is. Looks like I got that one off a hair. But it doesn't matter. Because if you're going to make a threaded tab to weld, I'll go in there and I'll get it all lined up and tack them on there with the welder. That's all it needs to hold that cover plate on it. You don't need a lot of heat, just a friggin' good tack. In my early days, I'd figure out I needed a tab and make one, and then later I'd figure out I needed more. And this is a way to do it on a piece of stock. And then I'll go to the bandsaw, snip, 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 snip. Ready to rip. I'd say that the first full test of the system is a success.